Today we're going to be talking about lesson 8.1, Measures of Center. So this starts our new unit, Unit 8, on statistics. And our objective today is, given a set of data, I can correctly calculate the mean, median, and mode in 3 out of 3 problems. These are known as measures of center. Some of them probably sound familiar. Maybe you've done a few of these. We've actually done the mean in this class already this year. Maybe you've seen the others. Maybe you haven't. That's okay. We will review them for today for those who have seen it. First off, these measures of center apply to something called univariate data. Now this is a fancy word, but if we take it apart, uni, that means one, and variate means variable. So if we put that together, this is data we collect about one particular variable, one particular kind of thing. So for example, we might be collecting data about travel times, time it takes to travel in your car someplace. So these might be the various travel times in your car. Or maybe we are taking data on several different puppies and the weights of different puppies. Notice too that data doesn't have to be numbers. It could be words, it could be things we describe things. So for instance, could be books we check out from the library. Notice we don't have numbers here, but we do have different categories of books. Notice also that these can be repeated. That makes sense because you can check out more than one sci-fi book from the library. So values in data can be repeated. Here's another example down here of repeated values. More than one student's favorite color was purple. And numbers can be repeated as well. This isn't limited to just the description words. So we're going to talk about measures of center today. And average or arithmetic mean is what we formally call it. What do we use averages for? When do you hear about averages? Like if you hear about them on the news, you hear about like the average American. The average American eats however many calories each day. What does that mean? How do we think about that? If it's the average American, what does that mean? Does that mean every single American eats 85 grams of fat a day? Or does it mean that some do and some don't? What is an average telling us about a group of people or a group of things or a group of measurements? Or what if we said the average student studies 15 hours a week? Does that mean every student studies 15 hours a week? Or it might mean something more like the typical student studies 15 hours a week. Or we might think of it as common. The common student, or a student commonly studies 15 hours a week. And deviations from that are more exceptions than they are the rule. So this is a way to generalize an entire group of data into one number. We think of it as kind of the middle, or the typical example of such a thing, and we use them to generalize the whole group. So it's a number or a figure or a value we take to represent the entire set of things. And that's why we calculate these measures of center, because we need a way to represent large groups of things. We need a way to think about them in an aggregated way. So the 3 measures of center we're going to talk about today are mean, median, and mode. Mean is probably the one you'll see the most in real life, and also the one we're probably most familiar with right now. Median, however, is still very useful. It's the middle value. Mode is used less often, but it does have applicable times. It is the most common value. It's the value that pops up the most often. We'll talk about what those cases are when you'll want to use mode. So let's start off with mean. Let's look at our mean first, the one we might be familiar with or most familiar with. This is where we take the sum of the values, we add them all up, put them in the numerator, and then we divide them by the count. So we also call this an average, but formally we call it a mean, an arithmetic mean. So let's calculate the mean on these examples. Remember, the mean is going to be the sum over the count. And then we have some instructions down here also if we forget. Add all the values, that's a sum, and then count and put in the denominator. So here we go. Let's add these numbers, 6 plus 10 plus 4 plus 8. And then we count them, 1, 2, 3, 4. So we divide by 4. 6 plus 10 is 16, plus 4 is 20, plus 8 is 28. So we get 28 over 4, which divides evenly into 7. 7 is our mean for that set of data. Let's try this one. 5 plus 0 plus 10 plus 6 plus 4. Notice I did keep the 0. 0 is a valid piece of data. Sometimes we measure things to be 0. So we do keep it. And then on the bottom, we're going to count. 1, 2, 3, 4, 5. So on the top we have 5 plus 0 is 5, plus 10 is 15, plus 6 is 21, plus 4 is 25. And 25 divided by 5 is 5. So 5 is our mean. Last one on this page, we add these numbers in the numerator and divide by the count. 1, 2, 3, 4 in the bottom. 7 plus 4 is 11, 11 plus 6 is 17, 17 plus 5 is 22. And 22 divided by 4 is 5.5. Notice we got a decimal here, which is totally possible in a mean. Because we're dividing by a count, that means we could divide by 7, we could divide by 25, we could divide by any number really, any positive number. So we will get lots of decimals when we're calculating the mean. Now there are cases where we actually can skip some of these steps because they did them for us. Let's read this one. A team of 6 bakers made 30 cakes for a bake sale. How many cakes did each baker make on average? Well, remember, we want the sum over the count. So each baker made some number of cakes. We don't know how many each one made, but we do know that the sum of all of them is 30. And the count of all the bakers is 6. So if we want the average, we'll just take the sum over the count, which is 30 over 6. And our answer is 5. 5 cakes per baker on average. Now this one's a little bit harder. This is actually a totally useful problem because this is legitimately how your grades are calculated. So if you want to do this exercise on your own grades, you can. Emilio earned scores of 87, 80, 75, and 85 on 4 tests. What score must he earn on the next test to have a mean of 85? Now to make this easier to set up, how we might set this up, or how we might write this initially is, our set of data is this, 87, 80, 75, 85, and then we have an unknown for the next test. So we can use a variable. We like to use the variable x. This is our full set of data now, including this new unknown test. Now if we want to do the mean of this set of data, we're going to do the sum over the count, like we do. So we add them all together, 87 plus 80 plus 75 plus 85 plus this unknown x we're going to bring with us. And our count is 1, 2, 3, 4, 5, including the unknown. And now we can set that equal to 85 because that's what we want the mean to be, a mean of 85. So we just set that equal to 85. And now this is an equation in one variable. We can solve it. So let's see, I'm going to get out my calculator and add these first four numbers together. 87 plus 80 plus 75 plus 85. I get 327 plus x. And everything just comes with us, everything else. Now we're going to solve for x. So we get rid of the term that's further away. We multiply both sides by 5 because that's the inverse operation of divide. 327 plus x is what's left over here. 85 times 5, I'll do in my calculator. That is 425. Now we just need to subtract 327 from both sides. Subtract 327 as the inverse operation to add. And we get x equals, looks like this is 98. So Amelia will have to score quite high on this last test in order to bring the average or the mean up to 85. He'll have to get a score of 98. And once again, this is in fact how your grades right now are calculated. They are calculated with an arithmetic mean. So we get an average, we get a mean, and then we apply a grade to it. So if you're wondering how many points you need, you can use this exact process on the current points in your class. All right, before we move on to the next measure of center, I want to spend just a minute on rounding. We looked at rounding a little bit last unit, but I want to make sure we're totally clear on what we do with rounding. So let's say we want to round this number right here, this number, to the nearest tenth. So we have a decimal place. The one right after the decimal is the tenths place. The one after that is the hundredths place, and the one after that is the thousandths place. What we mean by that, what those words mean, a tenths place, is that you can think of it like we're dividing by 10. This is 5 over 10. And this one is 3 over 100. And this one is 1 over 1,000. So if we want to round this to the nearest tenth, that means our answer is going to have a tenths place in it. So I like to draw a line right where I expect my answer to end. I'm going to have a decimal point and then a tenths place and then nothing else. So now that I have this line, I decide whatever's after it, is it going to round down or round up? If it rounds down, then this number would go down to a 5. If it rounds up, then this number is going to round up to a 6. So we have to decide if we're rounding down or rounding up, and then we get rid of everything after the line. Well, we looked at this next number and we say if it's 5 or above, we're going to go up. If it's 4 or below, we're going to go down. So this is a 3, that's below 4, so that tells us we're going to go down. We're going to go down, and this rounds down to 5. So our full answer here, rounding to the tenths place, is 28.5. Let's do a few rounding problems just to make sure we're clear on how to do this. We want to round 5.6482 to the nearest hundredth. So I'm going to draw a line after the hundredths place. I ask, do I round up or down based on this 8? That 8 is going to round up, so this tenth value, or this hundredth value rather, goes up to a 5. Our final rounded answer here is 5.65. Let's do the next one. Round 0.3520 to the nearest tenth. You try this one. Pause the video, try this one, and then see if we get the same answer. I'll draw my line at the tenth. I look at this 5. I say 5 rounds up. And so this 3 is going to go up. 0.4 is our answer. Try this next one on your own as well. Come back, see if we get the same answer. So this one's a little bit tricky. We're not even going to have a decimal point on this one. We're going to draw the line actually on the decimal point. We're rounding to the nearest whole number. So we look at this 2, we say that goes down. So 6 stays a 6. And that is just our final answer there. Rounded to the nearest whole number, 6.2741 becomes 6 by itself. So that's a quick review of rounding just to make sure we know how to do it. Rounding will come up a lot when we're doing the mean. All right, let's return to our measures of center. We're finished with mean for the moment. Now we're going to look at median. Median is the middle number. And how we're going to find that is by writing the numbers in order, and then we find the middle number. If there is no specific middle number, so if you have an even number of data points, you're going to have to find the value in between the two middle ones. So let's look at some examples of how we do that. The first step we need to do is to write these values in order, in increasing order. So let's see, 1 is our smallest, then 4, then 6, then 7, then 10. Those are our values. And now we can do this little trick where we cross out the first and the last and the new first and the last until we're left with just one number. If we're left with just one number, that is the mean. Or sorry, that's the median. The median is 6 in this case. So let's try this next one. We need to write the numbers in order. Remember, we do keep 0. So 0 is our smallest, then 2, then 5, then 8, then 16. We're going to cross out first and last, and we are left with 5. So 5 is our median in this case. All right, next one. Again, we keep 0. We write these in order. 3, 7, 11. Now I'll cross out my first and my last, but look at this. I'm left with 2. If I crossed first and last out again, I'd have nothing left. I have to find a value that would be in the middle here, in the middle between 3 and 7. And the way we do that is we just find the mean between them. We find the value that's immediately between them. Now you may even be able to visualize this one. If you think of it like on a number line 3 to 7, you might be able to see in your head that 5 is right between them. So that's the number we're going to expect here. But the way you can calculate the mean of two numbers, once again, we're finding the middle of these two. We just add them together and divide by the count, right? So divide by 2. 3 plus 7 is 10, divided by 2 is 5. So 5 is our median in this case. It's the number that's right between these middle two. Even though it's not part of our data set, it is the value that's in the middle of our middle values. All right, let's try one more. Notice we have repeat numbers here. We have a 4 twice. We do keep repeats, repeat values. Remember, purple can be two people's favorite color. So 3, 4, 4, 9, 12, 14 is our numbers in order. We'll cross out first and last, and now we need to find the number in between 4 and 9. So we can take 4 plus 9 divided by 2 to find what number is in between them. 13 over 2 is going to be 6.5. So 6.5 is our median in this case. That's how we find it if we have an even number of data points. All right, that's it for median. We are on to our last measure of center, which is mode. Now, mode is the most common value, and this is the one that's used least. This is the one that is not very commonly used. But you'll notice this little note down here. Mode is the only relevant measure of center for non-numeric data. So if I said, for instance, what is the typical genre of book checked out from the library, it wouldn't make much sense to be like 7.8. It's not a numeric data point. None of the data we collected on this is numeric. So we can't actually calculate a mean or a median. We could only use mode. We could say, well, just standard fiction is the most commonly checked out. So that's going to be our representative value. That would be our mode in that case. A couple exceptions to keep in mind here. If there is no repeating value in your data set, then there is no mode. And if there is a tie, then it's called multimodal. There are more than one mode. So let's look at some examples of mode here. Let's find the mode in this one. Well, let's see. If I look through, I see 2 2s. It looks like we have 3 4s. So 4 is our mode in that one. How about in the second one? Well, I see 2 23s, so looks like nothing else repeats. Notice the difference between these two. These ones were not ordered. These ones are ordered. While it is not strictly necessary to order these numbers, it can be very helpful because you can basically see groupings at that point. So we say over here in our steps, it's optional to write the values in order, but I do recommend it. It can be very helpful. How about this last one? We've got some non-numeric data down here, maybe choices of snacks. Which one do you see most common? Apples comes up 3 times, so that is the mode in this particular case. So that covers everything on mode. Let's just do a quick summary here. This is a great one to take a picture of for your notes. A summary of mean, median, and mode. And we'll just go through a couple of examples now to make sure we've got these ideas solidified in our head. So we want to calculate the mean, median, and mode for this set of data. So let's see, we have the mean, we have the median, and we have the mode. Mean is going to be sum over count. So we get, I'm just going to put these all in my calculator rather than writing them out. 4 plus 4 plus 7 plus 6 plus 8 plus 6 plus 6 is 41. And I count them 1, 2, 3, 4, 5, 6, 7. So 41 divided by 7 is 5.857. And it keeps going on. It might ask us to round to the nearest tenth, in which case we would say this is 5.9. The median, for the median we need to write these in order. So 4, 4, those are our smallest ones, then 6, 6, 6, 7, 8. So median, we are going to cross out our first and last, first and last, first and last, and we are left with 6 for the median. And then mode is pretty easy to see once these are ordered. We can see we have 3 6s, 2 4s, and then 1 7 and 1 8. So 6 is also the mode. 5.9 is the median, or 5.9 is the mean, 6 is the median, and 6 is the mode. They are very close in this case, but they don't need to be. They can be very different numbers. Let's try one more example. Calculate the mean, median, and mode for this data set. So we have different winter activities. Let's see, we have 2 ice skating, 2 skiing, and then 1, 2, 3 sledding. Okay, so mean, median, and mode. Well, I think we just figured out the mode. We said sledding happens 3 times, so that's going to be our mode. What about the mean? How do we calculate the mean? How do we do a sum over a count here? Well, I could count them, 1, 2, 3, 4, 5, 6, 7, 8. So our count is 8. But how would I do a sum of these values? How would I sum ice skating and skiing and sledding? How would I add those together? You can't. You can't perform a mean on non-numeric data. Same with the median. You can't order these numerically. So there's no median and there's no mean for non-numeric data. So the only measure of center we have here is sledding, and that is the mode. So that wraps up today's objective. Given a set of data, I can correctly calculate the mean, median, and mode in 3 out of 3 problems.